A lot of the materials that we use are based on carbon, so we cannot build them without carbon. What we can do is build them not on fossil carbon, but on renewable. We are going to take CO2 from the air and convert it into renewable chemical feedstocks. So we will put a lot of electrical energy in the CO2, and this will allow the once stable molecule of CO2 to become unstable and be vulnerable for chemical reactions. And then by bringing water into the equation, we basically can create what we call hydrocarbons.
Electrochemically, we can make ethylene, carbon monoxide or formic acid from CO2. These are actually the building blocks for a lot of carbon-based molecules in the entire industry. For example, ethylene is used as a precursor for plastics, carbon monoxide for fuels, and formic acid has a lot of end applications like cleaning products, like descaling, like de-icing. We now have developed a prototype of our electrolyzer, which is producing kilograms of formic acid per day. We want to scale this up to higher kilowatt scale or to megawatt scale.
From there we want to grow towards multiple plants, first in Europe and later all over the world. What we are looking for is partnerships through the entire value for potential customers who are interested in our products and want to work together with us to see if our materials meet their criteria. But we are also looking on the CO2 side of the value chain. So big companies with big CO2 emissions and who want to give an economical value to this CO2 that they capture. But we are also looking together in working with people on the logistics side to help us with basically setting up the entire value chain. CO2 is a big problem. We need to be able to work together and reverse climate warming.